So this is actually one of my favorite problems that I put into the packet for you because it's a little bit different than all the others. So in this you have a function that has derivatives of all orders at x equals 0, so that you can take the derivative as many times as you want. That p sub n of x denote the nth degree Taylor polynomial of f around x equals 0, so that's the Maclaurin series, Maclaurin polynomial. It's known that f of 0 equals -4, and that p sub 1, which is the first degree Taylor polynomial, is -3. Show that f prime of 0 is 2. So if you were trying to generate a Maclaurin series, in general, the Maclaurin series formula starts at 0, goes to infinity, and you have the nth derivative at 0 times x to the n over n factorial. So if I wanted the first degree, I would have f of 0, x to the 0 over 0 factorial, which is 1, plus f prime of 0, x to the first over 1 factorial, which is 1. So this is the first degree Taylor polynomial. Well, they tell you that f of 0 is -4, and that this polynomial, when you plug in 1/2 for x, it gives you -3. That's enough information to find f prime of 0. So if I add 1 to both sides, I get f prime, 1/2 of f prime of 0 equals 1, which means that f prime of 0 is 2, which is exactly what they're asking to prove. So for part B, it's known that f double prime of 0 is -2/3, and f triple prime of 0 is 1/3. Find p3 of x, that's the third degree Maclaurin polynomial. So we've already got the first two terms because we have this -4, and we just found f prime of 0, which was 2. And that's times x to the first over 1 factorial. Then the next two terms would be f double prime of 0, x squared over 2 factorial, plus f triple prime of 0, x to the third over 3 factorial. Now they tell you f double prime of 0 is -2/3, and f triple prime of 0 is 1/3. So literally that's just replacing those things. So let's see, f double prime was -2/3, so this is going to become a negative. 2 factorial is 2, so 2/3 will simplify down to 1/3 with that 2 on the bottom. So we've got x squared over 3. And then f triple prime was 1/3. 3 factorial is 6, so it's going to make this thing 1/18 x cubed. And that's an 18, not an 8. All right. So there's P3. So if I'm looking now at part C, h has the first derivative given by h prime of x equals f of 2x. It is known that h of 0 is 7. Find the third degree Taylor polynomial for h about x equals 0. So h prime of x is f of 2x. And this was a polynomial that represented f of x. So what I'm going to do is find f of 2x, which is going to be -4 plus 4x minus, that would be 4x squared over 3. And this would be 8 over 18, which is, 4 over 9? 4/9 x cubed. And this represents h prime. So now they're saying find h if you know that h of 0 is 7. So that means we're taking the antiderivative of this thing. So h of x would be -4x plus 2x squared. Increase the power by 1, divide by the new power. 4x cubed over 9. And then this would be 1/9 x to the 4th. Plus c. Now, that plus c is important because we know that h of 0 is 7. So when I do h of 0, which is 7, all these terms are going to go away and leave you with c. So the c is 7, and it was asking you for the third degree Taylor polynomial. So I only want to take this thing up to the third degree. So let's see, -4x plus 2x squared minus 4x cubed over 9 plus 7. I could put 7 in front, I just didn't. So that's it.